Okay, so with this new amazing tool of electrolysis, we now see how chemists in the early 1800s were able to discover, many elements. They just did what we did with other solutions of, with minerals dissolved in solutions. They would even also just run electricity through molten substances as well. So that's actually how sodium was discovered. They melted salt, table salt, big blocks of it, and just ran tons of electricity through it. I was mentioning before that to isolate sodium, you need a lot of electricity. So they actually didn't do it in solution. They did it with molten halite or molten sodium chloride, and bam, out pops this super reactive, toxic, exciting metal, sodium. Anyways, this is where we are. We are clearly no longer in a 4-element universe. We're in an unknown number of chemical element universe. Antoine Lavoisier recognized this. He was the first one, at least in the West, to write out a detailed or sort of a list of all the elements known to chemists at the time. And this was really the game for the next 100 years after Lavoisier is, can we come up with a list of all these elements? And the whole point of, one major point of coming up with the list was to see if there's any order or any pattern amongst these elements. As I mentioned before, this was a kind of a disorienting or time. Scientists were not at ease with all of these new chemical elements being discovered, because the order that was once believed to be kind of understood was clearly breaking apart. But as you know, scientists have a faith that there is order in the universe and that we can sort of make sense of it the best we can. And so this is what Antoine Lavoisier was doing by listing out 30 or so of the elements known at the time in the late 1700s. He actually got a few things wrong. He named heat as an element. We know heat is not an element. It doesn't even have mass. He also named lime as an element, and lime is just the name for the mineral calcium oxide. So we now know lime is not a pure element. It is made of calcium and oxygen. So he got that wrong. But the spirit or the essence of what he was doing was right on. And this is what we'll continue to do, not in just in this short course, but throughout this entire year of chemistry, to try to make sense of all this newly discovered elements. And so just in terms of like how scientists determined or could definitively say if an element was an element, I touched on this before. Basically, if it couldn't be broken down any further, then it was an element. And then the goal was to sort of define the element by a set of properties: heating, melting point, boiling point, density, electrical conductivity, heat conductivity, and one other property was chemical reactivity. And this is actually what we'll focus in on in this lab. Is the goal and the challenge will be to outline and identify the relative chemical reactivity of a series of metals: magnesium, zinc, aluminum, copper, and iron. So these 5 metals, your goal will be to list in order of reactivity. So of these 5 metals, what is most reactive and what is least reactive, and what we'll react them with. And you actually, in the first course, we reacted some of these metals with hydrochloric acid. So we know that we react with acid. So we'll just use vinegar. So we'll react each of these metals with vinegar. And your job will be to order these metals by reactivity. Which one's the most reactive? Which one's the least reactive? So let's go do it.